Given the root of a binary tree, we need to invert the tree and return its root. So for example, if this is the tree, then we would need to invert, or in other words, flip the tree around its vertical axis. So the result would look like this. Notice that all the nodes that were left nodes are now right nodes, and all the right nodes have become left nodes. And by doing so, we've produced a tree that is a mirror image of the original one. Now, like many other binary tree problems, this can be solved by using recursion and depth-first search, and that's the approach we're going to use. If you're not comfortable with recursion and binary trees, I'd recommend you first practice on some easier problems, and I've included links to similar problems in the description. So now let's look at the code and solve this in Python. Let's say that this is the tree that we are given. The root would then be this top node in blue. We'll then begin to recursively invert the tree, but only if the root is not none. In other words, the base case is when the root is none. Right now, the root is a node with a value of 1, so let's enter this if block and begin inverting. The first thing we'll do is create a variable called left that points to the same node as root.left. So that's going to be this node with a value of 2. You'll see why we need this variable later, but the reason is because if we don't create this variable, we'll end up losing our reference to that node. So now it's time for the actual recursion. We'll recursively invert the right subtree and assign that subtree to root.left so that it becomes the left subtree. Then we'll do the same thing with the other side and recursively invert the left subtree and assign the result to root.right. So let's start by inverting the right subtree by recursively calling InvertTree again and passing in root.right. I'll leave a blue dot here to keep track of where we left off in the function where the blue node is the root. So let's enter the recursive call, but now notice that root.right was none. So in this new function call, root is none. That means we've hit the base case and there's nothing left to invert in this subtree. So we can skip this if block and simply return root. Now we're back in the function where the blue node is the root, and this function returned none. So now we're going to assign none to root.left, and this is where it can get kind of confusing. So when we assign a value to root.left, we are changing the node that this pointer in red points to. So instead of pointing to the node with a value of 2, we're going to point it to the value that was returned, which is none, like this. Now you can see that both root.left and root.right are pointing to none. And this is also the reason why we needed the left variable that we created earlier. If we didn't have it, then there would be no more references to the left subtree and it would be lost forever. But since we do have that left variable, we can now move on and invert the left subtree. So again, let's enter this function and leave a blue dot here, and now the root in the new function is the orange node. This root is not none, so we'll have to invert this subtree as well. Again, let's create a pointer called left to point to the left subtree, and then we'll invert the right subtree by passing in root.right. I'll leave an orange dot here this time since we're in the function where the orange node is the root, and let's enter another recursive call. However, now notice that root is finally none, so we'll just return root and come back here. Similar to last time, we now have to point root.left to none, but since it's already pointing to none, I don't need to change anything visually. Then let's do the left side. This is going to be the same as the right branch, where we'll enter the function, but root is none, so we'll return root and go back here. We'll now point root.right to none, but again, since it's already pointing to none, visually nothing changes. We've now finished inverting the subtree with the orange node as the root, so we're ready to return to the original tree, and we're going to return the orange node with a value of 2. So let's go back here and point root.right to node number 2. I'm going to move over the root.left pointer to make some space, and now let's point root.right to node number 2, like this. We've now finished inverting the entire binary tree, so we can finally exit the main function and return root, which is the node in blue. And as you can see, we've recursively inverted the entire tree, and we're done.